Hi folks, in this video we're going to be looking at how to make and test Ethernet network cables. Network cables and patch cables are used to connect many different devices together, such as PCs, servers, routers, switches, printers, TVs, and even CCTV cameras. They carry the data from device to device and can also be used in some cases to carry power to devices like wireless access points and CCTV cameras using something called PoE, or Power over Ethernet. Although you can buy ready-made network patch cables in assorted sizes, sometimes these ready-made cables can work out to be quite expensive. However, prices can vary dramatically from one supplier to another. Also, if you need to run long lengths of cable throughout a building, usually you would have to pull the cable through conduit or some small holes in walls and ceilings, and so it makes sense to fit the plugs on afterwards, as they might otherwise get stuck or damaged. When it comes to Ethernet networks, there are several different grades of network cable. For this video, we're going to look at Category 5 Enhanced, or CAT5E, and Category 6 cables, as these are commonly in use today and are essentially connected the same way. CAT5E works for network speeds of up to about 1000 megabits, or 1 gigabit. But if you are making up cabling for a new installation, it would be worth spending a little extra and getting CAT6, as it can handle speeds up to 10 gigabits. Both CAT5E and CAT6 cables are made up of a set of 8 wires that are divided into 4 separate pairs. The individual wires in each pair are then twisted around each other, and this helps to prevent the wires from picking up electromagnetic interference that they may absorb from other wires and devices nearby. When the pairs of wire in a cable are twisted around each other like that, we call the cable unshielded twisted pair cable, or UTP. Here we can see the plastic core in the center, and here's another view just showing the core a bit more clearly. If you're in an electrically noisy environment like a factory with many powerful electric motors and machinery, these devices will create a lot of electromagnetic interference, or EMI. And in this case, you might want to use what is known as screened or foiled twisted pair. This type of cable surrounds all of the pairs in a foil wrapping to block out any interference, which might corrupt the data that is traveling through the cable. Here you can see the foil shield has been peeled away, and it also reveals the ground wire running throughout. There's also a plastic cover over the wires just to help to protect them. The ground wire that we just saw then connects to the metal cover on the plug. The plug is pretty much the same as a normal RJ45. It has a metal cover on the outside. And then this connects with the ground connection in the socket. So before we make the cable, let's just have a quick look at the order in which the wires are going to be placed. So here we have a diagram showing an RJ45 plug. We have a side view up at the top, and then on the right hand side we have a view looking at it from above. So this wiring scheme is known as the 568B wiring scheme, and that's the one that's currently in use. And so we have 8 wires, and those 8 wires are put in the order of white, orange, orange, white, green, blue, white, blue, green, and white, brown, brown. Okay, so let's look at some of the stuff that we're going to need. Okay, so first you're going to need an RJ45 crimp tool. These cost about 20 to 30 euros or dollars. Next, you're going to need some either CAT5E or CAT6 cable. You can buy these in boxes of about 300 meters for prices varying from about 60 to 160 euros or dollars, depending on whether it's CAT5E or CAT6, and some brands are better than others. CAT6 is a better grade of cable with thicker copper wires, so it tends to be more expensive. Next, some RJ45 plugs. You should choose these based on whether you're using CAT5E or CAT6. Although they can be interchangeable, it can be difficult fitting CAT6 wire into CAT5 plugs, as the wires are that little bit thicker. And finally, although not absolutely necessary, it can be handy to have a cable tester to check that your cables are working properly. These cost about 15 to 20 euros or dollars. So the first thing we need to do is cut a piece of cable. So I'm just going to use the crimp tool to do that. And what we use here is the blade at this point. So let's just do this, put our cable in here, and then just chop. There we go. There's a cable cut. Okay, so once we have our cable then, the next thing we're going to need to do is strip off some of this insulation. And we need to strip off enough of the insulation to allow us to manipulate the wires inside it properly. So although it might be tempting to just cut off a small amount, you really need to take off a bit more. So what I'm going to do is cut off about this much. Now the way we do it is we put the cable into this little groove here, and then what we want to do is score the outside. So we just gently close, and then we twist around like this. So we've gone around the whole wire, and then we should be able to separate like this, and then just pull the insulation right off. Now at this point, you can see that we have 4 different pairs of wires. So we have green and white, brown and white, blue and white, and orange and white. And there's also this fine fiber here as well, which has a couple of different purposes, but we'll talk about that later. So the next thing we need to do then is to separate out all of these wires. So it's a little bit of a fiddly process. So we just have to separate them out like this using our hands until we have them all separated out. That's one pair, then the next pair, and then the next pair. And we just keep going until we get them all done. So it can be a little bit tedious, but here we go. We got the last set now. Okay, so now they're all separated out. Now the thing we have to remember is the order in which the cables or the wires are going to go into our plug. So the first thing we need to do is just straighten these out. If you catch them between your fingers like that and just pull, it should help to straighten them out. Okay, it's very important to do that, because if they're not straightened out, they're not going to fit together very well inside the plug. So just run them through like that until you have them all done. Okay, so at this point then we can start to arrange them. So I'm just going to take this little piece here and remove it because we don't really need it. So just use the crimp tool again. Okay. So here are our wires, and we need to put them in the right order. So the first one is white-orange. Next one is orange. Next one is white-green. So that's the white-green one. So white, orange, orange, white, green. And then the next one is blue. So sometimes they can be a little awkward to arrange in that order. So white, orange, orange, white, green, blue. Then a white, blue. And then green. And then white, brown. And then brown. Okay, and as I said, keep pulling them like that, straighten them out, makes them go together easier. So white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. So now we have them in the right order. Next thing we have to do then is trim them to size. So we only want them to be long enough to reach up from this point up to the tip of those metal pins. So we're going to take off quite a lot, but I'm not going to do that yet. I'm going to take off some of it now. So just make sure they're in order again. White, orange, orange, white, green, blue, white, blue, green, brown, brown. And then what we do is just give it a haircut. Okay. So what we can do now is just push them in. Okay, now a lot of people will just make their plug like that. Okay, but there's a problem here. The purple insulation here needs to go all the way up inside the plug, up to about here. Okay, because there's a little barb here that needs to be pressed down. And once that's pressed down, it will hold the insulation tightly so that the plug won't be easy to pull off. So we need to take it out again. Make sure you hold the wires. Okay, then we need to trim off a bit more. Now there should be level on the top as well, okay, or at least reasonably level. So let's put them in again. So white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. Now it's looking better. Okay, and if we look real close, you can see that the wire is going up the side here, up past the little brass pins or gold pins. Okay, and the same on this side with the brown wire. And you can even see the end. Sometimes you can see the wires sticking out the end there. Okay, but it's still a little bit too short because that purple bit is not quite reaching all the way up. So I'm going to trim off just a little bit more. So just a small amount now. And it's really important as well that you don't end up with one wire that's a little bit longer than the others, because that will prevent the wires traveling up inside the plug properly. So almost there, just a little bit more. Okay, and it's very important as well when you're cutting to make sure that they're still in the same order. Okay, so now you can see that the purple insulation is reaching all the way up as far as it can go inside the plug. Okay, you can see it there as well. So now we need to get the crimp tool again. At this time we're going to use the crimp tool to actually crimp on the plug. Okay, so this is where we use this part of the crimp tool. So we take our plug and we fit it in here like this. Okay, and then what we need to do is close down the crimp tool until the blade that's here reaches this point. We don't want it to actually touch, but just about touch. So you do have to squeeze quite tightly to do this. Okay, and sometimes you may need to do it a couple of times. So I'm just going to take it out and have a look. So you can see the pins have been pushed down. And I'm just going to give it another crimp anyway. I always do it 2 times. Okay, so push this back in here. Make sure, and then give it a good squeeze. Okay, and now you can see that it's fairly well tightened down. Okay, all the pins are pressed down fully, so that's good. Okay, so next we need to put a plug on the other end, so I won't do that here. We'll come back in a minute once I have that done. Okay, so I've made up the other plug, and here we have the 2 plugs now at this stage. And if you look carefully at them, you can see that they are both in the same order. So when you're looking at your plug, you know, the clip, this little clippy thing, that should be facing down. Okay, and then the colors should be in this order on both sides. Now, if we look real close as well, you should be able to see that on the side of the plug, you can see that the brown wire there is traveling all the way up through to the very end. And the little golden plug, or little golden pin, is sticking straight into the wire. So we've got a good connection there. Okay, and you can also look at the top part of the plug, and you can see that all the wires are reaching up pretty much to the end. Doesn't seem to be any issues there. Okay, and the purple insulation is running right up as far as it can go. And also that all the gold pins have been properly pushed down into the plug. If we look at a different one that hasn't been crimped yet, you should see that there's a slight difference, that the pins are more raised. You can see them sticking up there, whereas in this one beside it, they've been pushed down into the plug. Okay, so the next thing we want to do then is test the cable. Okay, so to test the cable, we just need to get a cable tester like this and turn it on. Okay, and then with this cable tester, it has two different pieces that you can remove like that. And if you look at the top of them, they have different sockets in them. So this one has RJ45 and RJ11 connectors. Okay, and same with this one. It has RJ45 and RJ11. So you can use it to test phone lines as well. Okay, and then you can just join it together like that. So what we want to do is we want to test our RJ45 network cable. So for that, we're going to click one end in here and the other end in here. And another thing I do actually, when I'm testing a wire, I usually don't hold the plug when I'm pushing it in. If you've crimped it properly, it should plug in easily without being forced. If you haven't fully crimped it down enough, then if you were to push it into the socket, you may damage the socket because the pins inside the plug aren't fully pushed down, so they may end up squashing the springs inside the socket. So it's very important, you know, if you're finding it difficult to put the plug into the socket, then take it back out and crimp it again. I just mean, you know, squeeze it again in the crimp tool just to kind of make sure those pins are pushed properly down. Okay, so once you're happy with that and the plug goes in easily enough, you can just look at the lights on the tester tool, and what should happen is the corresponding lights should turn on at the same time. So 1, 2, 3, 4, 5, 6, 7, 8, and then G is for if you had a shielded cable, that would be for the ground. Okay, so in this case, this is not a shielded cable, this is unshielded twisted pair. So the G light is not going to turn on. But you can see they're all lighting up in the right order. So that means each one of our wires is properly connected at both ends of the cable. So this is a good cable. You can use these testers as well to, well, the reason you can take off these bits is that if you had a really long cable you wanted to test, you could have this connected at one end, and then you could send somebody down to the other end and get them to check are the lights coming on at the same time as the ones at your end. Always make sure to turn off your cable tester when you're finished with it. I have another cable tester. It's very similar, pretty much the same kind of thing, just looks a little bit different. And that's this one here. Again, two different halves, comes apart. And then we just plug in our cable. Should hear a little click when I plug it in. In most cases you should anyway, like this one here. Okay, and then we just press the button and you can see the order of the lights. They all seem to be good. Okay, so we know we have a good cable. I mentioned before that if you're not careful and don't properly crimp your plugs, you can damage your cable tester. So what that means is that if we look inside here, inside the sockets of the cable tester, you can see that there are some little wires here, and they actually kind of go up at an angle about 45 degrees or maybe 30 degrees. And if they get squashed down too much, they won't come back up again properly. And so they won't make proper connections with your plugs when you're testing them. So it's very important, you know, make sure you crimp your plugs before you force them into the sockets. Okay. Here's an example of a plug that hasn't really been fitted very well. You can see here that the insulations part of the wire is not inside the plug, so it kind of would be easy enough to pull that apart. There's also another little issue with this. It's hard to see here, but just at this point you can see that one of the pins hasn't been properly crimped. Now it is making contact with the wire, but it is sticking up a bit out of the plug, and that can be damaging to any sockets that it's plugged into. So just something to look out for. Another way you can use to test a network cable, if you don't happen to have a cable tester and you happen to have a multimeter, is to set your multimeter to the continuity setting, which is this little icon here. And then what you can do, it's a bit fiddly, but you can do it, is to take your probes from your multimeter and put one on the first pin of one and one on the pin of the other one. And if you get a beep, that means there's a connection. Then you move on to the next. Check for a beep again. There we go, there's a beep. And you move on to the next one and so on. And that way you can check that each of the wires are connected at both ends. I said I'd take a look at the strand of fibers that runs through the cable as well. Now, not all cables have this, but a lot of them do. And it's there for a couple of reasons. One is it gives the cable extra strength when it's being pulled through conduit and through holes in walls and things like that. So it just makes it stronger, puts less strain on the actual copper strands. And then another thing you can do with this as well is you can use it to actually tear down the side of the wire, and then it helps you to expose more of these so that you can work on them. Sometimes it's used when connecting up telephone wires as well. So it's just a handy little trick you can do there. Okay. Just one thing as well in relation to CAT6 cables. This is a piece of CAT6 cable here, and you can see the center part that is used to separate the 4 pairs of wires. So as I said earlier, this gives the cable extra strength, but when you're trying to put the plug on it though, you'll need to cut that. So the best thing to do is just peel back your wires like that, and then just get a pair of snips and cut that piece out. There we go. Okay, once that's done, you'll be able to then put your cable together properly. Okay, folks, thanks for watching. Don't forget to smash that like button, and if you'd like to see more videos like this, don't forget to subscribe. See you next time.